Good afternoon. You are looking live at the Chapter 1 check-in with me, your host, Mr. Goldman. I am outside, so if you hear any birds chirping, do not be alarmed. Standard 1. A probability of 0.25 is unlikely, because if I have a number line here, I'll just put it up here. 0 to 1, all probabilities are between those two numbers. 1/2, this would be equally likely. 0 is impossible. 1 is certain. So anything in this range is going to be unlikely. Anything in this range, all the way up to 1, is going to be likely. Since 0.25 is 1/4, that goes right there. It is in the unlikely section. 2, probability of 0 is impossible. No way it can happen. Number 3, a probability of 0.99. That's going to be right around here. Notice it is very close to 1, but it is not exactly 1, so it's not necessarily certain. It's very likely. It's the equivalent of 99% likely, but it is not certain. Standard 2. Nicholas rolls a fair number cubed 350 times. What is a reasonable number of times that an even number will appear? Well, the probability of getting an even number is 1/2. Remember, this is theoretical. We're going to use the theoretical to predict experimental. Predict the outcomes of an experiment, right? So my experimental is number of trials is my denominator, which is going to be 350. So one of the ways I can do this is 1/2 times some giant 1, because I don't want to change the value, equals 350 over what? Well, my giant 1 would look like, not 150, woohoo! 175 over 175, so the numerator would be 175. Remember, in experimental, this is the number of trials, and 175 would be the expected number of desired outcomes. Right? So 175, notice none of these are exactly 175. However, 175 is very close to 177. All right. A couple other ways you can do it. You could have just divided 350 by 2 because you know that half of the rolls would be even, or you would expect half the rolls to be even. But if you did that, make sure you explain why you're dividing by 2. Don't just do something without explaining it. Standard 3. A bag contains 3 blue buttons and 7 green buttons. I'm just going to stop right here because that's all the information I need in order to determine theoretical probability. The theoretical probability of getting blue, there's 3 blue buttons, so 3 desired outcomes over 10 total buttons. Remember, desired outcomes, number of desired over, this can be thought of as sample space. 10 total buttons in the sample space. You reach into the bag and pull out a button at random 20 times. So I'm doing an experiment 20 times. So that's going to be my denominator in experimental probability. Replacing the buttons each time. You get 9 blue buttons and 11 green buttons. Notice the 9 and the 11 add up to 20. But I have 9 blue buttons. That's what I'm looking for. So I have 9 over 20. Again, experimental is going to be number of desired outcomes over, in this case, instead of sample space, it's sample size, or the number of trials in an experiment. So 3 over 10, 9 over 20, you can write this as 0.3, 0.45, 6 over 20 if you wanted to get common denominators so we can more easily compare them. Notice they're not identical, which is okay, and that's to be expected, especially with the sample size as low as 20. Number 6, there are 20 boys in a classroom of 45 students. If you randomly choose one student from the class, what is the probability it will be a girl? Well, if I have 45 total students and I subtract 20 boys, I'm going to get 25 girls. So I know that there are 25 girls, that's my desired outcome, over a total of 45 students. So 25 over 45, which is equivalent, if you wanted to simplify, to 5/9. Moving on. Number 7. Mr. Goldman reaches into a bag filled with 64 chocolates, 24 milk chocolates. So I have milk is 24, and 14 dark chocolate. Dark is 14, 64 total. The rest are chocolate with sea salt. Ooh. A bit of a trick, because you might think you needed to find how many sea salt chocolates there are, but we actually don't, because I want to find probability of milk or dark. We can think of this as probability of milk, or means addition plus the probability of dark. So if I break this up, the probability of milk, there's 24 milk over 64 total. I'm going to add the probability of dark. There's 14 dark over 64 total. If I add those together, I get 38 64ths. And we can simplify that to 19 32nds. I'll just leave it as 38 64ths because I'm lazy. But either one of those answers is acceptable. Moving on to the review standard. Calculate the area and perimeter of each of the following shapes. Work must be shown for credit. For perimeter of a rectangle, a few ways I can do this. I like to do 2 times 2.2 meters plus 4 meters. That means I take this, add it to that, and then double it to find the missing area. So that's 2 times 2.2 meters plus 4 meters is 6.2 meters. And then 2 times that is 12.4 meters. You need to have the meters in your answer. You don't necessarily have to write it here, but it is helpful. Area. Area of a rectangle is length times width. So my area equals 2.2 meters times 4 meters. My area equals 2.2 times 4 is 8.8. Meters times meters is meters squared. 8.8 meters squared. Moving on to the triangle. Perimeter is just add the outside. I do not need to worry about the height, which is 12. So I have 12.3 inches plus 12.3 inches plus 5 inches. If I add those up, I get 29.6 inches for the perimeter of a triangle. The area of a triangle is base times height divided by 2. I'll put a little t here, a little r here, just to be clear. I'm talking about area of a rectangle, area of a triangle. So area of the triangle is, my base is 5 inches, times my height is 12 inches. Make sure we're using this as the height. Remember, they are perpendicular to each other. They form a corner or a right angle. And do not forget to divide by 2. I'll just do 12 divided by 2 and get 6. 5 inches times 6 inches. Area of a triangle is not 60. Woohoo! 30 inches squared. Make sure that's area of a rectangle. All right. Last one. Perimeter of the trapezoid. Again, I'm just adding these 4 sides. So I have 15 kilometers plus 10 kilometers plus 15 kilometers plus 12 kilometers. If I add those up, I get 52 kilometers. For area of a trapezoid is base 1 plus base 2 divided by 2 times height. Plugging in my information, area of a trapezoid, I'll say base 1 is 12 kilometers plus base 2 is 10 kilometers, right? These 2 sides here. I'm going to divide that by 2 and then multiply by my height, which is not 15 but 14 kilometers. Area of a trap, 12 plus 10 kilometers is 22 kilometers, divided by 2 is 11 kilometers. times 14 kilometers. Area of a trapezoid, 11 times 14 is 154. Kilometers times kilometers is kilometers squared. And there you have it. Good luck on your retest.